Hello guys, welcome back. And today we're gonna keep doing chapter 1 and 1b relations and domain range. As we know, the order the pair for the domain denotes which is like x and y, and that's representing the points coordinates. And relation instead of order the pairs, for example, we do 1, 1, 1, 2, 3, 4, 5, 6, and this all is done, is all the coordinates, the points. And the set of the first coordinates, which is in x values, that means the domain. And it's the second coordinates, which is y values, that means the range. And some relations may be like a rule relating as like y equal to x plus 1, and your x only belong to 1, 2, 3, 4, which is the couple of points 1, 1, oh, sorry, 1, 2, 2, 3, 3, 4, and 4, 5. And they can be, they will happen sometimes. And that's the rule, like relating. And representing relations, which is domain of the relations, a set of real number R. Then we have infinitely points. For example, we have domain is a real number, range is the real number. That was a linear relation, y equal to x plus 1. Sometimes we will say the arrow diagrams, which is arrow diagrams looks like. A couple of examples like that. We could do the quick examples like 6 minus 2x equal to 3y, and both sides can divide by 3. That both become to y equal to 6 on 2x. So which is y equal to minus 2 on third x plus 2. And if we write the linear relation, you could draw the graph, and you can say x and y, and that looks like the cross of 2, and then your graph like that, pretty much. And your domain is real number, and the range is belong to a real number. And sometimes like that, the actually domain is given to you. It's negative 1 to 2. Sorry, my mistake. Both can including the negative 1 and 2. So if we draw the graph, we can draw when x equal to negative 1, y equal to negative 2 minus y equal to minus 3, and x equal to 2, y equal to 4 minus y equal to 3. So, and then if we draw the graph, it'll be like this one. So x and y, sorry about that. And I should use the ruler. And well, don't try to copy me like that. So make sure you use the ruler, draw the Cartesian plan. Okay, please. Yeah, anyway, there is negative 1 to negative 3 and 2 to 3. So we have 2 points connected, like that. Perfect, that's it. And do not over the line and point, please, because they give you the domain. So just stop there and dot points and dot points. You could mention 2, 3. Well, I'm not gonna stop you with that because they're gonna be help you the extra as well. So then tell me your domain is and tell me your range is. Range looks like from negative 3 to 3. There you go. And example 2, sketch the graph. Sometimes we will sketch the graph like the quadratic formulas. So quadratics as well. So we could draw the graph like that, and the domain is all real number, which is from negative infinity to infinity. So we could do is we need to find when y equal to 0, which is x-intercept. So can anyone tell me about this one? Give you guys a minute, and then turns out we actually find out x minus x minus 1 and x minus 5 equal to 0. That doesn't exist, so we could use quadratic formula. So which is like that. B squared minus 4ac. So that equal to that equal to 2a, which is 2, and 4 plus or minus 16 minus 4ac, 4ac, which is 2, 4 plus or minus 16 minus 4 times a times 5. Turns out, guess what? B squared minus 4ac less than 0. So there's no solution for x-intercept. So we could draw the graph straight away, like you find the point. So you could do is x and y. So x and y across the 5. So can we find the turning points instead? So let's find turning points instead. So we could do is turning points. So TP representing turning points, which is x equal to negative 2a. So b minus 2a is divided by 2a. And then we actually try to figure out what we actually do is to find out turning points is. And then that equal to 4 over 2. This is 2. So when x equal to 2, so we could do is adding all together, which is y equal to 2 squared minus 8 plus 5. So that's only 1, so which is 2. 1 is our turning points. Perfect. So we find out 2, 1, 2, 1 is our turning points. And then could draw the quadratics like that. Turning points. And there you go. You find out your graph and sketching, and then turns out domain is real number, range is real number. Perfect. Actually, range is not a real number. My mistake. Range actually equal to 1 to positive infinity. There you go. Sometimes I make mistake as well. So question B we will do in class actually. Let's try to do that in challenging. And sketching the graph relations, which is x squared plus 2. Sometimes they actually set up in between. So which is when x equal to negative 2, y equal to 6, x equal to 1, y equal to 3. If you say if the range is from 3 to 6, you might be wrong because that's the quadratics. You have to draw the graph. And tell me, looks like the turning point is between negative 2 to 1. So your negative 2 is equal to 6. Your y equal to 3 and x equal to 1, so which is here. Okay. Let's find out the minimum. So we could do finding the turning points, as I said, x equal to negative 2a and then b over 2a, so which is turns out 0. So when x equal to 0, and that's equal to 2, and we also quickly find out this our turning points, and which is gonna be like that. Okay, 1, 3, and 2, -2, 6. And suddenly, once you find out your turning point is 0, 2, which is your range equal to 2 to 6. There you go. Make sure it's the minimum to maximum. And here is another word. It's called implicit domain, which is when we have a relation writing, no domain is specified. And then understood that the domain take the largest, which is the rule has meaning something. And the domain is called the maximi or implicit domain. So as we say the implicit domain, we could do something with like this question. So give a minute and then you guys can start doing the question. And this one I can start with. So x minus 1 squared plus y squared is the 9. So actually, I can show you this one looks like a circle. And then, because your center of the circle will be moved to the right direction by 1 unit, and then your radius equal to 3. So your looks like that. So which is, this one is 4, this one is -2, this one is yeah, this one is 1, this one is 1. So let's go. And yeah, looks like that. And can you tell me your maximum point? So actually the domain range, implicit domain is from -2 to 4, so which is -2 to 4. -2 to 4 is your domain. And range will be equal to a substitution in here. So which is 1, 3 and 1, -3. So which is -3 to 3. Yeah. And sometimes we will have some square root like that. So we will do these questions during the class as well. All right, thanks for listening, and then I will see you in the class.